deliver the welcome address. May I request you, sir, kindly address the gallery.
Very good morning to all. It gives me immense pleasure and honor to extend a warm and cordial welcome to this esteemed gathering at the 2026 International Conference on Innovation in Emerging Technologies for Sustainable Development, organized by Center of Promotion of Research, King's College of Engineering. At the outset, I extend my respectful greetings to our beloved Principal Madam, whose constant encouragement and visionary leadership have been backbone of the conference. I would also like to warmly welcome Vice Principal, Conference Convener, the heads of the various department and the faculty members. It is my privilege to extend a heartfelt welcome to our distinguished keynote speaker, Dr. B. Nagarajan sir, Professor, Department of Electronics Engineering, Pondicherry University. Welcome, sir. Who will be delivering the keynote address on AI in signal processing. Sir, your presence today adds great value to this conference, and we are eager to gain insight from your vast knowledge and expertise. I also take this opportunity to warmly welcome all the participants, researchers, academicians, and students who have gathered here to share knowledge, exchange ideas, and explore innovation in emerging technologies for sustainable development. Once again, I extend a warm welcome to one and all. Let us make this session highly insightful and inspiring. Thank you all.
Thank you, sir, for your gracious words of welcome. A keynote address is not just a speech. It is a doorway to new ideas and perspectives. We now move on to the most vital segment of this session. It's my privilege to introduce our distinguished keynote speaker, Dr. B. Nagarajan, Professor, Department of Electronics Engineering, Pondicherry University, Pondicherry. He is an eminent academician and researcher whose contributions have significantly enriched the field of engineering and technology. Today's keynote focuses on a highly relevant and exciting topic, AI in signal processing. At the mind, it's my privilege to introduce our distinguished keynote speaker, Dr. B. Nagarajan sir, Professor, Department of Electronics Engineering, Pondicherry University, Pondicherry. He is an eminent academician and researcher whose contributions have significantly enriched the field of engineering and technology. Today's keynote focuses on a highly relevant and exciting topic, AI in signal processing. At the mind where intelligence meets innovation, transforming the way signals are analyzed, interpreted, and utilized in real-world applications. Now, with great honor and anticipation, I invite Dr. B. Nagarajan sir to deliver the keynote address. Sir, the stage is yours.
Good morning to all. The respected Principal and Conference Chair, Dr. J. Alpudavili Vijayasri Madam, and Secretary of King's College of Engineering,
Dr. R. Rajendran, and Professor from National Institute of Technology, Dr. N. Sivakumaran sir, and the editorial chair and vice principal of King's College of Education, Dr. N. Sivakumaran sir, and other faculty members and students from the various colleges and this King's College of Engineering. A very happy and wonderful occasion to share about the signal processing applications with you at this juncture. So our students know about that what it means, what are the things to be highlighted, and what are the things are very important to be focused. You know that activity is not practical in electronics engineering. It is a one platform that all professionals can share their knowledge and collaboratively we can work together and focus on your career, and you can get a lot of information. In the electrical and electronics, there is a different field, electronics and electric field. They invented Alexander Graham Bell invented telephone. So he wanted to highlight, he wanted to give the results to the all. So what is the platform? How we can transfer our knowledge? So he thought it and he found one rule. So like that in electrical, the electricity, Edison, Thomas was Edison, and invented the electricity. After that, this is a bulb. Okay, bulb, we invented the bulb. So how we can transfer the knowledge to the professional students and then budding engineers or budding pupils to do the research. So he created one separate group for electrical engineers. So Gagaman formed one group for electronics engineer, and Edison formed one group for electrical engineers. Then after that they combined both. Why we are organizing that separate platform? So we can, because they are doing that combined with the research. So the research should be distributed to that all many of people. So they formed the group and they started the Institute of Electrical and Electronic Engineers. That is IEEE. We used to call it IEEE. So now in IEEE, under that IEEE, one umbrella, we are having that all new technologies, AI, robotics, electronics, instrumentations, and solid state. So many things, what are the researches are available. It is available in the IEEE platform. So throughout the world, I think around 184 countries, they are using the IEEE standards, and you can publish your papers. And what are the things, new technologies? This is it is the main authority and authorized agent. You can get the current concept and what are the things you want to refer it, you can refer it from the IEEE. For especially for engineering students. So many journals are available. Springer, Wiley, so many things are there, but the journals are basically used for arts and various fields. But this is actually one used for especially for engineers. So through the IEEE, once you are getting the commitments, you can access all content and you can develop skills. Okay. So IEEE is a kind platform. You can focus and you can develop and you can enrich your knowledge in various aspects. So I am happy to give the keynote speech in this area in signal processing. Just mic. So in signal processing, there is a lot of information because of signal processing and artificial intelligence and many topics you could get it from that IEEE. So you are having that job or you are having that any issues directly, secondly, if you are having a membership, which you can see that video and any whatever the doubts you are getting, you can directly contact the IEEE members and you can make it the resources and you can address it. Okay, that type of facilities are available. IEEE. So IEEE is having that different societies are there. Okay, every different societies are there for different subjects. So very much interested in particular subject, and particular subject you can get the membership and you can go through it and you can develop your skills. So many outcome you can get it. Okay. So this one, AI signal processing. You know about that artificial intelligence and signal processing. You know about that next. Signal processing. Signal is any physical quantity which varying with respect to any independent variable which used to convey the useful information. Whereas that signal is used to give the useful information. Okay. So, any type of signal should be there, but it should be given that specific information output. That signal we have to process it. So any input is there. That's for example, we are making the vegetables, we are making the food or any dish, our convenience, our travel, we have to cook it. Isn't it? Like this. Many signals are available. From the signal, how we can definitely get the desired outcome. So that is the process. So artificial intelligence. Now nowadays we are talking about the artificial intelligence. That AI. It used to give that correct decisions based upon the set of rules. Rules are there. We can violate the rule. But this artificial intelligence depend upon the situations, depend upon the environment, depend upon the schedule. It used to give that output. So artificial intelligence is transforming signal processing by enabling faster, more accurate and adaptive methods of analyzing, filtering, classifying and predicting signals across multiple domains. So, what are the signals? Suppose, for example, you are in the traffic. So nowadays traffic, east, west, north, south, so 4 directions are there. So people are there. So they are waiting for their signal. If red, green, yellow, so these signals indicates they start and they have to wait and they can cross the road. This is the normal routine procedures. A, B, C, D, 4 directions are there. So this is a routine process, what we are expecting, with a normal signal. But in A, so depend upon the crowd, it take the decision. Suppose A said, B said, C, D. So A they used to open and B next is C, D. In this order, our traffic could be there. But A, based upon the number of users are available in that area. Okay, that's particular environment and particular timing based upon the crowd it used to decide. So instead of C, B, it opens D because it used to give that preference to the environment and the situations based upon the input data. So that is the adaptive decision and clever decision based upon the input and the parameters. Okay, so that's why artificial intelligence is transforming signal processing by enabling faster, okay, very speedy processor and more accurate and adaptive method. Adaptive method of analyzing means wherever that the clouds are available, okay, clouds are available, we can release the traffic. We can release the traffic. That decisions that we take care. Next. Next. First. Please. Yes. This is a simple mathematical view. Traditional y of t equal to x of t h of t. Okay, traditional method now y of t is output. Okay, s of t is our signal, whatever signal we are transmitting. H of t is the channel matrix. That is channel we are transmitting. Channel, this is the wireless communication. This is the channel, previous alarm. Fiber optical communication. Fiber is a channel. Coaxial, that is a cable. That is coaxial cable is a channel. Channel means we are transmitting that information in that free phase. Generally, that wireless communications. In wireless communication, the channel is a free phase. So that is in mathematically we are representing. Y of t equal to x of t, h of t. Y of t is our receive signal. Whatever I am delivering. So this is input x of t. This is the x of t. This information is transferred to your end. So your end means directly it will not reach in your place. Okay. Here so many obstacles are there. So here tables are there, mic, and so many things are there. So this whatever information it expresses that multiple propagation. So in this field phase and it reaches to our end. Okay, that is the channel condition. That's why what about the channel? For going to say any particular place now, we used to get that information. Any traffic or the otherwise climate is good or not. So this information we are collecting. No? So that is then the channel estimation. We used to do that channel estimation. That is a channel. So A, B is there. In between channel would be there. In wireless communication, without any physical connection, we can communicate. Okay, so the medium, so there is a channel is playing that vital role. So we have to know about the channel. That is very, very important. So this is general traditional method. Y of t equal to x of t cross h of t. So it used to do this is this area. Tanjavur King's College today based upon that predicted value. So today we are not expecting that rain. So like that it used to give. Okay. So based upon this traditional network used to work. But here A base y equal to f of theta x means every time it used to update. Every time it used to update. So for example, we used to conduct an internal exam and external exam. So many exams are there, 3 exams and main exam we are conducting. The first semesters are coming for 1 month, 1 unit. For staffs are taking that 1 unit, you are attending. And the second unit, third unit, you are not coming and attending the class. Okay, so straight away you are going to attend the exam. You are not updating the second 2 units. First unit, you are attending, no? So directly you are going. So, suppose question paper is covering that 5 questions, first unit only used to attend. So not updating. Okay, this is the general criteria for easy analysis. But here, each and every times, okay, each and every times is used to check the environment conditions. So this one to do, this is predicted already that past that reference value also it used to take and at present value also it used to take and based upon this it will used to give that decision. So that's why that y equal to f of theta x, where f not equal to neural networks land parameter. Theta x land parameters. So land parameters means we know that what could be the situations. Suppose we are having that any trouble in our body now, some symptoms we used to get based upon our experience. Suppose fever, any fever means body will be overheated, otherwise tiredness. This used to indicate some problem we are having. Okay, so if it continues for 2 days, 3 days, 4 days means dengue fever or malaria fever, you have to check it, no, based upon that info. Like this, it is like a doctor to identify the disease, no, federal doctors are there, no. So like this, here in neural networks, learn parameters y equal to f naught. This is each and every time it used to update it. Update it is very, very important. So based upon this, it used to take the decision. General network, y of t equal to x of t, h of t. That is, what are the signals we are transmitting in the channel conditioner? Already this channel would be like that. Based upon this, it reacts. But here, y of t equal to f of theta x. So it used to react based upon the updated parameter. This is artificial intelligence based AI based systems. Next. AI in signal processing. Signal processing traditionally relies on mathematical transform, Fourier, wavelet, Hilbert, and statistical model. Because you know about the mathematical that Fourier and Maxwell equation would have familiar with that electromagnetic theory. Okay, so electromagnetic waves, how it reacts. Okay, 1 plus 1 equal to 2, we know that. But the electromagnetic wave, how it reacts. So here also, wherever you go, electromagnets are there. How it reacts. Suppose electromagnetic is on this sharp surface, how it will react. Okay, so whatever that information we are transmitting, that information has to experience that LOS and NLOS condition. That is line of sight condition and not line of sight conditions. Line of sight conditions means both the transmitter and receiver could be there, and there is no obstacles between that A and B. But generally, the wireless communication environment and our whatever that in the 6G, we are in the period of 5G to 6G, 5G, fifth generation communication system. This environment is a non-line of sight condition. Non-line of sight condition means that A and B, both the transmitter and receiver, okay, should be not visible to each other. So whatever the information we are transmitting, it will be reaching and B by experiencing the multiple propagations. Okay, multiple propagation. That is impinging on that any surface, but it experiences the reflection and scattering. These three types of propagation it experiences and reach to the other end. So here we have to calculate that signal power, that and all. Okay, so this type of parameters we have to update, and based upon this one, it is generally that mobile phone we are using and we are speaking, and opposite fellows are hearing that words and we are communicating. But what are the processes is going on? That is the very important. So everything is at the mathematical model. So Fourier it used to give Maxwell equation 1, Maxwell equation 2, Maxwell equation 3. This 3 equations used to give that what is the electric field intensity and magnetic field and the power of the electromagnetic signal. Okay, electric field. What is the electric field strength of that particular this point? Okay, electric field. What is the magnetic field intensity of this particular area? By using that mathematical analysis, it used to give that value. So how they are calculating their percentage? 60%, 70%, 80% means based upon the average we are calculating, no, like that. In mathematically we are analyzing that wave characters, electromagnetic wave characters by using that equations. The equations used to give that clear picture about that waves actions and that theoretical aspects. Okay. So that means, so that's why that signal processing traditionally a mathematical transform. Mathematically, before going to implement in real time, the mathematical concept are used to use the statistical model. Okay. So that's why that we are analyzing that channel radiation fading and relay fading. Okay, radiation fading and relay fading. Relay fading means it occurs in that NLOS condition, not line of sight condition. So we are considering that LOS, satellite communication, okay, we can use that LOS. LOS, we assume that is both the transmitter and receiver should be meeting that some point, okay, visible to each other. So we are taking the relay model. Okay, these are the separate models to be there. So like that's different coffee, that is ginger tea, and so many varieties are there, no? So right now that particular recipe we can take and we can prepare that tea coffee. Like that, for these channel conditions, this type of fading is occurs, no? We can take that model and we can process it, and based upon this we can improve the SNR, signal to noise ratio, that is signal strength. Okay, so everything is depend upon that power. Generally, that wireless communication, but in EC, electronics and communication, wireless communications, it depend upon that signal strength, SNR and throughput. So what for we are going for the various generation, first generation, second generation, third generation, fourth generation, to achieve that high throughput. Okay, and anytime accessibility of that network. Throughput is nothing but number of information transmitted, number of information successfully received. That is the throughput. So whatever the information we are transmitting, and research that we are receiving. So like that, 40 papers are done, we are writing 40 papers in examinations, and out of 40, 38 papers are here now, what is the use? So that is throughput. Okay, 40, that is the number of information, number of bits transmitted, number of bits successfully received. And the signal strength. That information, whatever we are transmitting, signal strength should be higher than the noise ratio. Okay, noise ratio. That is exactly 20 to 25 dB. That's signal strength. That's why that we are speaking about while we are getting call. Sometimes we are getting the proper signal. Okay, proper signal, because the SNR is very low. That is noise is high, signal strength is very limited. So that's why this mathematical model we are analyzing, that time we can increase. So natural environment, like this particular place we are not getting the signal now. Definitely we can increase the signal strength. Suppose due to natural calamity, heavy rain, okay, so more traffic. So in that environment, there is no need to increase the signal strength. Okay, so what is going on in that particular situations? That is environment. Okay, so that time we have to restrict the give service for that this type of activities. Okay, that is the by knowing the environment. Okay, by knowing the environment. So that decision only that AI takes place. And with the growth of data-driven approaches, especially machine learning, deep learning is increasingly used to handle complex non-linear and dimensional signals. Etc. So what are the signals are there? Okay, so for example that what are the ECG, EEG and scan reports, what are they are taking now? So it is used to analyze, because the set of protocols that they are implementing, and they are based upon this, it used to give the accurate results. Next. Application of AI signal processing, speech and audio processing, speech recognition, noise reduction, speech enhancement. So what we are expecting, what we are experiencing nowadays, chat GPT. What are the information we are speaking now? We can convert it into audio. That audio also we can convert into any type of voice. That could be possible because of that analyzing the voice, pitch, everything. Okay, that voice we can convert it into text. That text also we can convert it into A, B, C version also. High level, low level, and accepted level. But we can easily convert by using the chat GPT, isn't it? That is a type of AI. Okay, what are the information I can talk? That my speech also I can convert into Chinese. That Chinese speech I can convert into text. Everything would be possible because of that. Everything, all parameters will be easily recognized and converted. Okay. So speech and audio processing would be possible. Noise reduction and speech enhancement. Very important is that is x of y of t equal to x of t h of t, because the channel condition noise is playing the important role. Okay, so we can avoid it. And emotion recognition from voice and music, something. this is the emotion regulation from voice. This is very, very important. Emotion, sometimes by speech itself we can easily know how in phone itself sometimes they are carrying easily we can analyze that is emotions. But in speech itself we can what situation that other end peoples are there easily we can recognize. That would be possible here. How and what they want to convey. That type of information we can get it. Next. Image and video processing. So whatever image you are taking, we can take it and in suppose we are giving into that Google chat now, convert into passport size, convert into this format I want, and I can increase our hair and I can change my color. Whatever information you are giving it, used to convert. So already the parameters are there. This is the input. This is the output. What I am expecting. What are the parameters I get? Then learn the parameters. Learn the parameters. Based upon this, you use to convert it. So object detection, regulation, self-driving cars and surveillance, medical imaging, MRI, CT, other techniques, video summation and anomaly detection, fault detection could be possible. Next. And we can use for biomedical, communication system, industrial and IoT application. These are the different application field. A plays the field role in communications. Next. Yes. AI is expected to play a critical role in the development and operation of 6G communication networks, enabling intelligent, adaptive and ultra-reliable wireless systems. So we are talking about first generation, second generation, third generation, fourth generation. That is improvement in that various generation. G for generation. First generation. So olden days we used to communicate. How we can communicate? Through BGM. By smoke signal we used to communicate. So rather than we used to communicate for the analog communication, first generations. Okay, only voice communication is possible. Okay, second generation, voice and data. And third generation, it's about multimedia. Multimedia is nothing but audio, video, data. And fourth generation, high speed. Fifth generation, very high speed. That means data will be improved. That is kilobit per second, megabit per second, gigabits per second, and 6G we are reaching 1 terabit per second. 1 terabit per second. Within fraction of time, we can download one movie and we can watch in our mobile phone itself. Okay, in 6G communication, we can interconnect all the devices. We can switch off the fan, switch off the AC, and everything will be possible. 6G generation because of the high throughput. That is ultra-reliable wireless communication. Very high speed communication would be possible, and the doctors can do the operation by using the rope. The Chinese doctor can do operation in India also could be possible because of that ultra-reliable. So 6G communication system, why we are moving now? We are getting that terabits per second. That is data rate is terabits per second. Okay, could be possible. Next. Yes. Please. Yes. AI link budget equation. Satellite. For example, we can consider that satellite communication. Okay, we know about the satellite communication. In classical satellite system used by ISRO, NASA model LEO system like space, the link budget is computed using the dynamic equation. AI improves prediction of losses, interference, and adaptive power control. What are the fading? Due to the signal losses is the signal strength. Okay, fading and interference from the other sources, intersymbol interference, adjacent channel interference. These are the interference we are getting. And power control inside the link, how we can activate and enable the activities of the satellite communication system. Okay, next. So classical link budget derivation, Friis transmission equations generally received power. So everything is based upon power. Okay, if mobile phone is not having the power now, we can't use it. We have to charge it. It's very, very important. No? This is the basic equation. You would have familiar with this. Friis. Received power is dependent upon the transmit power. PT. PT is nothing but transmitted power, and GT is nothing but antenna gain, and transmitting antenna gain. GR is nothing but receiver antenna gain. Lambda is equal to C by F, speed of light, C equal to 3 into 10 power 8, and F is what frequency, uplink and downlink frequency we are using. From here to from earth station to satellite and satellite to earth station. So uplink and downlink frequency what we are assigning 6 by 4 or 13, 12. Let's say depend upon that applications we can use that at different frequencies. So 4 by D, that is sphere. So we are using the sphere communication. So 4 by D is nothing but distance between the transmitter and the receiver. This is a general equation, lambda by 4 by D square. So the receiver power is dependent upon transmitter power, how much power transmitting, and these are the things we have to consider for receiver power. If receiver power is decreasing, there may be a fault in this area. GD, we are concentrating this and we are improving this, we can get the PR. If once our mobile phone charge is getting down, so we have to charge it. Okay, it used to give that indication. So receive power is less than, what is the fault? We have to consider. Okay, based upon the input. Next. So coming to this one is the receive power is dependent upon PT, JT, GR and total power loss. So power loss we are separating, we will be getting the receive power in dB. Okay. So the three-phase power loss depend upon 20 log 10 4 by 80 by lambda. The distance and sphere and lambda. These are the things power loss. Power loss transmitted to receiver. Extension to here, the power loss will be because the information is transferred from the extension to the satellite. So that power loss we have to calculate. That power loss, total power loss is what is the accepted level of power loss expected in the communication system. We can neglect it and we can calculate PR. We have some percentage could be there, no? 100. Okay, 100% are there now. Some how we can calculate the percentage? A grade, S grade, A grade, B grade. 92, 100, and 82, 90, 72, 80 is there, no? Like that here, the minimum acceptable power loss would be reduced. After that, we are using the PR dB, received power. Okay, that received power also getting down means we have to rectify it. Next. So this is a D in kilometer and F in gigahertz, including system losses. How we can calculate that system loss? Received power equal to transmitting power, transmitting gain of the antenna, the receiving gain of the antenna, and path loss, and atmospheric path loss, and rain and noise. The noise also different types. Okay, different types of noises are there. So path loss and atmospheric conditions and rain. And this time, every time rain, we are not getting the rain. Okay, so we have to consider it. And every time we are not getting the traffic. In this condition, that time the reserve power will be varying. So that is the reserve power, we have to accept it. If power loss is there, that time rain is there, that time reserve power will be somewhat different. Cloud is there, that time will be different. This everything will be arranged by the mathematical model. That's why that mathematical model is very important for the result accurate point of view. And total loss is dependent upon the rain, atmosphere, and noise. So that the reserve power is dependent upon this all noise and transmitted power and transmitting gain and receiver. This is the thing. So the receiver power we are calculating for that only we are not getting the signal working. That is the problem. So by letting the fire now, heavy rain is there, cyclone is there, you are letting that fire now, definitely it is not possible. Okay, in the open phase. Okay, in your house we are letting the fire, it is possible. Because of the cyclone, no, it is not possible. That is environment analysis. Okay, that's why this VR equal to PT is conveying that information. This information, these equations convey that received power is depend upon these parameters. When these parameters we are analyzing, we can increase and decrease. So like that our AC. Okay, so in a hot, the summer 21, 19, we are giving, we are getting the good cold. And suppose heavy rain, and during that time we have to keep 24 or 26 or 27 based upon the environment. So we are giving that input, no? That humans, we are giving that input. So the same thing, similar thing is system will functions. The system will function based upon the environment. That is artificial intelligence. Okay, what with the human? We are controlling the AC and these things based upon our body conditions. We need more cooling or we need less cooling. Okay, high temperature, low temperature, depending upon that, we are taking decision. No? That decision is taken by giving these parameters. Okay, mathematically we are conveying that information. Next. Carry to noise ratio direction. This is a noise power n equal to k to b. That is, noise power is dependent upon the Boltzmann constant. K to b, temperature, Boltzmann constant. Okay, K, D, B. That is n is dependent upon 10 log K plus 10 log D plus 10 log B. That is temperature of the environment. So we are simply saying that whatever information I am transmitting, I am not getting the signal. I am not, these are the things I am experiencing. This everything is included. They are considering what is the temperatures. Okay, the acceptable temperatures. And carry to noise ratio is received power minus n. That carrier power is dependent upon. We have to minimize and we have to separate the total noise from the received power. Then what is the carrier to noise ratio? Carrier to noise ratio. And substitute this, we will be getting the carrier to noise ratio equal to PT, GT, GT and L total minus K minus G minus B. So these things are available for transmitting that single information from earth station to satellite and satellite to earth stations. So this thing here is available. Next. So elimination of classical model. So these are general equations. General equations, noise we are considering, and temperatures we are considering, and interference we are considering, and receive and transmitting and this one is reference for getting that P of received power. Because power is very important. Without power, the communication systems will not act. Okay, so power is very important. Okay, so in real satellite system, rain fading is non-linear, atmospheric absorption varies, LEO satellite distance varies, that is LEO, GEO, MEO. So based upon that kilometer, based upon distance, we are separating that satellite. Okay, so we are locating at the satellite in a different type of orbit. Okay, so it used to capture that information and send that information to our send to that tap stations. That one we are using. So that satellite only capturing that all view of the that is like a Google map we are using. No? So it used to capture and it used to give that information to all of us. So just Google map we are typing this area I have to go. It used to give that satellite only giving that information. So that information is disturbed now. How we can get that information? So this mathematical model used to give that clear pictures. Okay. So LEO satellite distance varies and interface dynamic. Next. So AI based equation modeling. So we are modeling it. So if I am giving that amount to suppose you are giving amount to father and mother, how both are handling that amount? That is different. Mother will handle the amount in different way and father will handle that amount in different way. There is handling that amount is different way. No? So like it here, before that it consider the noise, atmospheric environment and temperatures, everything. Based upon it, it used to calculate the received power. If received power is less, we can increase and decrease and we can activate the communications. But we don't know the real scenario of that particular real scenario. But here, A-based liquidated modeling instead of determining loss, total loss is depend upon the total cost loss, atmospheric loss, and rain loss. That is, we model then F not equal to each and every time it used to update. That is the distance between the earth station and the satellite and F. That is what frequency we are using. For particular frequencies, particular noise will be influenced. And rain, humidity, elevation. Elevation is very important. Okay. So we are talking about satellite communication, elevation, altitude, and height. This thing we have to consider. Okay. So elevation and each and every time it used to update it. So for that only we are not getting the correct signals in satellite communication system. It used to give the information. Okay. And we are not equal to neural network 0 land parameters. This is the land parameters. It is used to give the information. Suppose if anybody asking your mark or anything, your class teachers will know your progress card. So when particular subject they are handling, signal system or any system, any subject they are handling, tell about the student. The class teachers know about your mark, what mark you scored, how you are behaving in the classroom, everything they used to do. That is they are the teachers is known as land parameters, theta. So okay, theta means they know about you. They used to give the information about you to any superior asking information about you. They used to give that information like that. So N A equal to F naught distance. This all parameters are there. But this is the distance. In this distance, this is a problem. Okay, because due to the rain, humidity, so we can keep that elevation in proper manner. So everything will be updated in that randomly used to adjust that all parameters. Next. Same based receipt power equations, modified in budget. PR, PT. So before that, PT plus GT, GR minus total R. We used to subtract that total R. That's all. Okay, so here D, F, rain, temperature, elevation, traffic load, all they are considering and updating it, and they are subtracting from that transmitting power and transmitting gain and receiving gain. That is the thing. Suppose if students are not attending the examination, they are asking some excuse from the staff members. Suppose they used to give that correct information, sometimes false information also they used to give. Okay, so based upon that, the staff used to verify whether he is giving that correct information or wrong information. Based upon that, they can take that decision. Sometimes not attending to postpone that examination or not willing to attend that examination, they used to give that wrong information. But they used to act. I am suffering from fever and they getting the medical certificate and all that. But the staffs are verifying it and used to verify it, and based upon this, they can give that review. So like that here, by based upon all parameters, not that based upon all parameters and learned parameters, it used to give the information to the system. That's why it acts as the perfectly, it gives that output. Okay, A, B. So there is a modification. Here, received power is dependent upon this one and updated. Blindly, it will not give that information. Okay, blindly, it will not give that information. Based upon the updated information. What is the updated? That is very important. So that's why that A plays that important role in the signal processing. Okay, next. A training derivations, training set, D equal to X actual. And this one means square. How it trains? Multiple times. Okay. Multiple times it used to train. Is not equal to 1 by summation of I equal to 1 to n. Actual and F naught. It used to train. It used to train that update that environment. 1 to 2, 2 to 3, 2 to 4. That what would be the environment conditions. It used to, every time it used to update it. Based upon this, we used to give that clear output. Okay, this is very important. That is actual x of t and this thing d equals. Okay, get training data set. Get the training data set, and based upon the training data set, we used to get the information. So many times we are reading the daily book now, we will be getting the more information. Today we are reading the one book now, some information. Tomorrow, day after tomorrow, so many concepts you can get it. Like this here, training data set, all input data and previous, and based upon this, you need to get the data. So optimization, theta argument minimum L naught theta, using gradient descent. The old and the theta updated after training L A equal to F naught of X. Yes. That means it's used to update the information. That's all. Updation is very important. That point L A equal to F naught X. It used to update the information. Based upon that updated information, it will use the output. Next. So this is the final A-based CBN extension, PT plus TT, that is carried to noise power. Okay, carried to noise power means noise power should be lesser than the carrier. Okay, they carry the information now, the carrier should be is having the high power. Then noise. So transmitted power, it depends upon the transmitted power, transmitted and gain and received and gain, and updated information. That means the distance between the transmitter and the receiver, and the rain, humidity, and temperature and loss. Everything is included in the F naught X and the ATP. This replaces static progress with intelligent predictions. Static progress loss. Okay, with intelligent prediction. The advantages in satellite systems, accurate rainfall predictions. So that's why it predicts that rain prediction. Before that, whenever they are announcing today they are getting that rain, that day they will not get that rain. But nowadays, whatever that information they are giving, definitely rain will come. Okay, that is the predictions. And adaptive power control could be possible. Adaptive power control, automatically, the natural environment is very worse, that time no need to boost the power. What is the need for giving that power? Okay, so if basically that environment is some issues are there. Crowd, that's not crowd area, a little bit crowded, more number of users are accessing the system, which explains that intersection we can improve and increase the power level. But throughout that area, experiencing the natural calamity, that time no need to give that good communication to that area. So that is adaptive power control. Improved bit error rate. 10 power minus 3. Suppose 10 power minus 3 means 1 by 1000. 1000 bits we are transmitting now. 1 bit might be getting that error. Okay, that bit error rate could be 10 power minus 5 is accepted. For general our communication system. And higher link availability, that is a 99 point link availability. Whenever we are trying, at least today we are 9 a.m. we are getting, at least 9192 we have to get it. So after we are getting that link, what is the use for that mobile phone? Okay, so that link availability is very important. That is suitable for carpenter and Leo system. Okay, so here everything, every concept, every equations are available. Just we are modifying it. Like for example, in hotel we are taking food and we are tasting. Whatever they are preparing, we can take the food. There is no issue. But in house, our mother or our loved one are preparing the food, we are liking more because they are adding some thing. Okay, adding some love. That love is equal to here artificial intelligence. That is that simple things that artificial intelligence modifying and improving the system performance. That things only that artificial intelligence are providing here. Okay, next. So, AI-driven network optimization. self-learning and self-automation networks. AI will enable zero-touch automation. RAM networks can optimize themselves without human interventions. So automation would be possible in the AI network. And dynamic resource allocations, AI algorithm will predict traffic demand and allocate resources dynamic to improve efficiency. So once, because here every time it used to update. By getting that updated knowledge, we can answer anything. Okay, so that is the information. That the information gathering is very, very important. So if you are having that, for example, all students are having that knowledge, but how we have to express it? The expressing persons will be getting that and will be recognized, isn't it? So whatever that things, what are the things high knowledge or individual performance are having, you have to expose it. You have to expose it. So once you are exposed and you are in building your confidence level only, will be recognized. So here, AI algorithm will predict traffic demand and allocate. Based upon what I informed in that about the different traffic, A, B, C, D is that depend upon that traffic condition, it used to release that particular road. Okay, particular signal. Okay, particular A, B, C, D. So generally that traffic signal is moving on A, B, C, D. So here, based depend upon that, how we can release that engine and any signals. That is the updated information. Algorithm results dynamic to improve. Here, ultimately we have to get that efficiency, improve the system efficiency. Next. So AI network optimization 60, real-time example with the derivations, introductions, latency means delay. Whatever we are going for that different type of communication system, delay should be avoided. Okay, millisecond or microsecond we have to get it, delay. Okay, delay should be avoided. And throughput, a number of successfully received information and energy efficiency and resource will be allocated for all. So real-time decision making, machine learning techniques such as deep reinforcement learning and automation, traffic management, handover decision, spectrum allocation dynamically. This is a very, very important concept. Okay, so this thing for 6G, how we can improve that? This thing we have to concentrate. How we can concentrate that? By updating it. So AI will take that. Okay, so that way the students are there. Some teacher used to give that advice. So many students are in a depression stage, or they are poor and they are not having confidence. The student, the staff members, the faculty members used to trigger them and trigger the students and kindle them for getting more confidence in that particular area. So many students will be benefited. Okay, like that here, that AI used to give the correct and accurate information about the environment. Next. So this is the real-time example AI with direct vector allocations. This is a system model. Channel capacity, achievable data rate. Data is dependent upon the bandwidth, noise, okay, the power and this channel gain. Okay, the channel entertainment. So this is a general equation. Okay, this is R is data rate allotted to user I is dependent upon the bandwidth and the power allocated B to the user A and the H, that is the channel gain, and B bandwidth of assigned to user I, A0 is the new nice power spectral. So this everything is dependent upon the achieving the high data rate. Okay, data rate is very important. Next. Please. Yes. So here the general equation is there, but here in the equations they are assigning the state code to maximize total network capacity while assigning the fair bandwidth and distributions. That is maximize the fair bandwidth. Summation of I equal to 1 to n, bandwidth log 1 plus P, H and N0. This one bandwidth constant. Bandwidth is very constant. So and the power constant. So power, received power is less than or P maximize. Some power limitation there less than or equal to. So power and bandwidth is here constant. Where concentrating on power and bandwidth, we can achieve the high throughput. That is the thing. So here, so I conclude with this. So what are the things now? For that particular persons are there, that particular persons, we have to degrade or something we have to do for that particular person. How we can degrade himself? Some particular informations we are throwing on him now. Definitely that person will do that confident. Some incident, isn't it? Some incident we are exploring, right? Exploring now. Definitely he will respond. And some pleasing ways we are doing that, he will be triggered and doing that. Some intelligent work. Some will degrade, some will discourage, some will encourage. This type of activities we can do. So that input they are capturing in AI model, and based upon this, we are improving this one now. The output will be improved. So if you want to score good marks now, that weekly at least 1 day you have to concentrate on particular subjects. At least 1 day for 7 days, definitely will be getting the pass mark. That is the important thing. That is 1 day. So each and that particular 1 day we are concentrating fully now, definitely you will be getting the pass mark. So that thing only we have to concentrate. Okay, that is which one we have to update it and particular 1 day. That similar thing here, AA, what are the parameters, what are the systems you are taking now? That system has to work now. For particular that AC is there. In AC, every 10 days we have to clean the inside one. Filter is there, air filter, we have to clean it. Okay, after that, regular 6 months once or 5 months once, we have to clear it. We have to go for service. These two things we are doing now. The AC automatically introduced to give good service. These two things we have to update it. 1 month once, the filter, we have to clear the filter, and next thing is the service, regular service. Okay, these two update every time. That like this in AI system, any system, this important parameter it used to take, and every time it updated information, and based upon this we are enjoying the facilities. Like this, you student also you have to set your own goal. How will be in next 1 year or 6 months or in futures. Based upon this, you have to put some schedule. Based on this, you have to work out now. We can achieve anything in any times. Okay, all the best.
For their invaluable contribution in making this conference a successful event. Thank you for this opportunity. Thank you all.
Thank you, ma'am, for beautifully capturing the essence of this conference. Growth begins where feedback is welcomed. We now open the floor for participants to share their experiences. Participants, kindly come forward to share your experiences. Participants from Chennai Institute of Technology, please come forward to share your feedback.
Ladies, what do you say? So, good morning everyone. I am Haridas from Chennai Institute of Technology. And so we are very much excited to participate, and this is our first conference for that. And our vendor shows have gave a suggestion that engineering college to apply. And we are thinking about pursuing it in a virtual manner, and hopefully we have contacted the engineering and they have told we need to come to a physical mode. And in physical mode, they have gave us so many suggestions regarding our conference purpose that it may work in a very much possible and not possible in that manner. And they have told us to improve a lot in conference purpose. And the content was a little bit need to be improvised. So this is the experience.
This is our first conference. First time we are just stepping outside from our college to just present about our project. So ma'am has told us a lot of correction to just optimize our project a bit more. And the speech about artificial intelligence was very insightful, and it was such a pleasure to meet you all guys, and thank you for this opportunity.
Thank you guys. Students from SRM Institute of Science and Technology, please come forward to share your valuable feedback.
Good afternoon, everyone. Myself Sri Saranya, and I am from SRM Institute of Science and Technology. I had a great experience in presenting in this conference, and I gained a lot of insights, differencing between real time and doing it as a prototype, and it was very useful. Thank you, sir, for giving us this opportunity for presenting in this conference.
Myself, Niranjana, I'm doing final year in SRM Institute of Science and Technology. This is my first conference, and I really got a different idea of how the questions will be from the reviewer's side, and it was nice, and it will be helpful for me to improvise my work.
I request the students from Radhalakshmi Engineering College to share their feedback. Radhalakshmi Engineering College. Students from Dr. Rangarajan, Dr. Shakuntala Engineering College. Wave Tech, High Tech.
Good afternoon, everyone. I'm Swati, and I feel it's very useful, and the way they explain us what we are and whatever things that we can improve in our project is very much helpful for us. And along with that, we learn a new thing from Sarah, extra, and I feel it's very useful to know something that I am not a little familiar with. So thank you so much, sir, for that. And thank you so much for the ma'am who reviewed us for providing a very beautiful stuff for us to improve our project. Thank you so much, sir.
Thank you, participants. Thank you for your valuable insights. And now the moment we have all been waiting for. Success is best when it is recognized. Now we want a moment of pride and celebration, the distribution of certificates. I request the dignitaries to kindly distribute the certificates. Mr. V.J. Kamlesh, Hari Priyadarshan, and Kishore Kumar from Chennai Institute of Technology. Kindly come forward to receive your certificates. Give them a great round of applause. Next comes Niranjana R, Chinnadurai, and Sri Saranya, Adipur Chakravarti from SRM Institute of Science and Technology. Students, please come forward to receive your certificate. Sukumar, Haridas, and Shanugapriya from Rajalakshmi Engineering College. They have presented their paper with the title Smart Mouse Based Voice Communication for Speech Impaired. JP Tamarasi, S. Mudra, and M. Swati, Dinesh Kumar, and Sivasarana Babu from Vedic High-Tech Dr. Rangarajan Dr. Shakuntala Engineering College, Chennai. Next comes R. Swati, K. Shakti Prabha, and M. Manju Prabha, B. Dayashi from King's College of Engineering. Next comes P. Kavita, Professor from Periyar Maniamma Institute of Science and Technology. Thank you, dignitaries. Gratitude turns what we have into enough. Now I would like to call upon Dr. P. Shankaraman sir to deliver the vote of thanks.
Respected dignitaries and distinguished guests, participants and my dear students, very good afternoon. First and foremost, I would like to thank our management and our secretary sir for providing the facility to conduct this conference and also permit us to conduct this conference under CPR. Very thank you very much, sir. And I thank our principal ma'am for continuous support and guidance throughout from the last 1 year. Thank you, ma'am. I would like to express our deep appreciation in our esteemed chief guest for inaugural session and especially the vote of valedictory section and keynote address. Madam, mainly from Chair, IEEE Sustainability Technical Committee, SSIT, Singapore, and our Academic Council member, Dr. N. Sukumaran, Professor, Department of IEEE, National Institute of Technology, Tiruchirappalli, and Conference Chair, IEEE Conference Chair, Madras Section, Dr. V. Nagarajan, Professor, Pondicherry University, whose presence and words have truly enriched this conference. We gratefully acknowledge the IEEE Madras Section and valuable associations and supports in organizing this event, and also we thank our IEEE Madras Section Chairman, Dr. B. Satyal, COE of Anna Institution, and my appreciation also goes to the Research Paper Review Committee members for all the dedicated efforts for maintaining high quality and standards of this conference. I would like to take a moment to extend my heartfelt thanks to our session chairs and session co-chairs for the 16 sessions which will be attended today and yesterday. I would like to especially thank all the participants from overseas and in India whose enthusiastic involvement made this conference lively and meaningful. And my gratitude goes to the Vice Principal Sir, COE, and all the HODs of this college, and also local organizing committee heads and its members for their continuous support and coordination. I also extend my gratitude to the CPR member and organizing this conference in a very successful manner. Finally, I thank on behalf of the Center for Promotion of Research everyone who contributed directly and indirectly to the successful of this conference. Thank you. Thank you, Honorable. Thank you very much.
Thank you, sir, for those heartfelt words of gratitude. With this, we conclude this valedictory session. Now I request everyone to rise for the national anthem.
पंजाब सिंध गुजरात मराठा द्राविड उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्चल जलसि तरंगा तव शुभ नामे जाहि तव शुभ आशीष माहि गाहे तव श्रेय गाथा जन गण मंगल नायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे.
As we come to the close of this incredible journey, let us remember this conference may end today, but the ideas ignited here will continue to grow, inspire, and transform the future. Thank you for your energy, your enthusiasm, and your excellence. Until we meet again.